Today we're going to be learning about current and potential difference through this example exam question. So the question says that the student investigates how current varies with potential difference for two different lamps. Her results are shown in this graph, which plots current in amps against potential difference in volts for both lamps, represented by two different lines. The first part of the question asks us to complete the circuit diagram for the circuit that the student could have used to obtain the results shown in the graph. Now, to first attempt this question, we need to know the three most important rules of circuits. Voltmeters are always placed in parallel with the component. Ammeters are always placed in series with the component, and batteries are always placed in series with the component and the ammeter. Okay, so when we construct our circuit diagram, we first need to start with the battery. So the battery goes at the top of our circuit, then we join it to a variable resistor. We need to use a variable resistor and not a normal resistor because, as you can see, the resistance changes. We then connect it to bulb A or bulb B. We put an ammeter in series with the component that we need to measure the current of, and we put a voltmeter in parallel with the bulb that we're trying to measure the potential difference of, according to our circuit rules. The next part of the question asks us which lamp will be brighter at any potential difference, and to explain our answer using the figure given. If we look to the graph, we can see that at any potential difference, lamp A has a higher current. If lamp A has a higher current, then that means it has a higher power output and is therefore brighter. We can also see this in our equation for power, which is current times potential difference. So if current goes up, that means power must also go up, and therefore lamp A is brighter. The third part of the question says lamp B has the higher resistance at any potential difference. How does the graph show this? Well, on the graph we can see that at any potential difference, lamp B has a much lower current than lamp A. We can tell this from the graph because of this shallow gradient. V equals IR tells us that if current goes down and potential difference stays constant, then resistance goes up. So, because we have a lower current, resistance must be higher at any potential difference. The fourth part of the question says that both lamps behave like ohmic conductors through a range of values of potential difference. Use the figure above to determine the range for these lamps. Now, this term ohmic is really key to the question. Ohmic means that it follows Ohm's law, which is V equals IR. Now, if it were to follow V equals IR, that would mean that current is proportional, directly proportional to potential difference, and resistance is constant. Now, if we remember that resistance is the gradient of the graph, for it to be constant, the gradient must be a straight line. However, we can see curving on our graph, and we can see curving in both lamps. But for it to be ohmic, the graph needs to be linear. So we need to find the place where the graph is linear or a straight line. If we zoom in, we can see that between 0 and 2 volts, the graph is pretty much a straight line. Because it's a straight line, we know that it is following Ohm's law, which is V equals IR. The resistance is constant, and the range of values in which it follows Ohm's law and behaves as an ohmic conductor is between 0 and 2 volts. Anywhere outside that region, it is a non-ohmic conductor, does not follow Ohm's law, and the resistance is not constant. Thank you for watching this tutorial. I hope you learned something.